Hi everyone, welcome back to another review video. Today we'll be reviewing briefly linked nodes, as well as these kind of tricky manipulation problems that are common when working with linked nodes in CSE 123. Very briefly, a linked node is an object that stores an element called data, and a reference that's a reference to another linked node, or it just looks like a linked node field. In this example, we have a node that points to another node and another node, as common when we work with linked nodes and see series of linked nodes as well. Here's the class representation again. Real briefly, some talking points are that we have two constructors, a single element constructor that just constructs data, as well as a two-element constructor that constructs data and constructs the next field. So this gives this linked node or list node another list node to point to when building it, as opposed to initializing next to null. And also the data field is final, so we're not allowed to change the data field. And keep this in mind when working with trying to manipulate or change list nodes later on in future problems. When working with list nodes, it's also occasionally helpful to create temp variables or temp references to already existing nodes. This allows us to change what a current node is pointing to without losing a node reference. For example, if we tried to change node to point to node.next, then we would lose this first node. However, if we created this temp variable, temp will point to the original node, and we're safe to change node to node.next without losing this first node. Oh, and keep in mind that creating a reference is not the same thing as creating an object. When we create a reference variable, we do not use the new keyword to create a new object. Instead, we're simply assigning a new reference variable to point to an existing object. Think about it in terms of arrows instead of actually assigning or creating an object with identical fields. And when doing these linked node manipulation problems, we need to keep this notion of a safe change in mind. I briefly talked about this when we were going over, okay, creating a temp variable is helpful because we don't lose a reference to a node. Well, we have set rules for making safe changes. The first one is if a node next field is null, it's safe to change that next field because we're not losing anything by changing null. A next field pointing to null or containing the value of null will not be lost, or null will not be lost if we change that next field to something else. So it's safe to change null. And second, as we touched on, it's safe to change a node that has two or more references pointing to it. Going back to this example, it's safe to change one of the references pointing to this first node because there are two references pointing to it. So we can move one of these without losing the actual node. And when neither of these options are available to us, then we can make a temporary variable to hold nodes. But watch out because you're often limited to how many temporary variables you can create. Here's a little exercise. Let's try to find the references that are safe to change. Well, the first rule is that if we have two or more references pointing to a node, it's safe to change one of those references. Does this ever occur? Well, if we look at temp and we look at node.next, they're both pointing to the second node. So it's okay to change one of those references because regardless, we'll have a reference to the second node if we change either node.next or temp. However, we can't change both. We need to keep one reference pointing to node.next in order for it to not be lost. Secondly, we also said that we're safe to change null references. So we can point this null next field to any node or maybe null again. That one's safe to change as well. And when we're solving manipulation problems, and we'll see an example coming up, there's sort of an algorithm that we can use. We can identify all possible changes, safe or unsafe, needed to reach the desired state of a linked node. It's always good to start with this by drawing out all possible changes needed to get to a desired state or your goal in order to see, okay, I need to make these changes in order to progress towards my end goal. Now, the second step, now that we have all of our possible changes that we need to make, is if any possible changes are safe, make one of those changes. Great. If we make safe changes that progress us to our goals one by one, we will reach the desired state in no time. Otherwise, if no possible changes are safe, we will probably need a temp node. So we can create a temp node pointing to a helpful node. And now at least one of those changes should be safe. I don't see a situation in which you created a temp node and then decide to point it to a linked list. So yeah, so there should be a one change that's safe. And now we can make a change that gets us one step closer to our desired goal, and then just repeat this process, making one safe step at a time. Oh, yeah, and if you're not drawing these problems out, you're doing it wrong. Because oftentimes we'll code up something and it makes sense to us, But once we write it out on paper, we see that the desired behavior that we thought was happening is not. So please draw out linked node problems. It'll save you so much time and effort in the long run, even if it takes a little longer in a short time or a short run. Now let's try a linked node manipulation problem. This problem is taken directly from Ed, but essentially it asks us to transform these two series of linked nodes, with one containing a list node of 1 and whose next field points to another list node containing 2, and the second series of linked nodes with the first node containing 3 and its next field pointing to another node that contains 4, to the following state: 3 with a list node of 3, 2, 1 in the first link, and a list node of only 4 in the second link. That's pretty much the whole problem. There is one note though. We may create a single list node variable or reference to refer to any existing node you'd like. So we're allowed to create a single temp variable to use in this problem, so keep that in the back of your minds. Here's the initial state of our linked nodes, and the goal is down below. As we make manipulations, we're going to track them in the box on the right. So first off, the first step in our algorithm was to draw out all possible changes that we need to make in order to reach this desired goal. And the current state is still blue, and the possible changes we need to make are in green. The next step is determining if any of these are safe to make. Well, we said our two rules were if 2 or more references point to the same node, we can change one of those references, or if a reference is node, we're free to change it. Well, we have one null reference, well, 2 actually, but one that we can change in order to get one step closer to this goal, in the form of p.next.next. This one is safe to change because it's just a null reference, and we can change it to whatever we'd like without worrying about losing a node. So let's make it. Let's make our next change. Well, are any of these safe to make? We can't change p, as only one node points to the node p is pointing to. We can't change p.next. We can't change q, and we can't change q.next without losing any nodes. So there are no safe changes to make. But remember what our algorithm said: if there are no safe changes, we can make a temp variable. So let's do that. I'm going to choose to make the change where q is now pointing to q.next, this thick arching arrow, and we're going to create a temp variable to do so. Let's create a temp variable pointing to q, or the node q is pointing to, so that way we can set q to whatever we want it to be. And we wanted to set q to q.next in order to be one step closer to this goal. In the box on the right, you can see we created a list node reference temp and pointed it to q. Great. Now this q change is safe. Since temp and q are both pointing to the list node containing 3, we're safe to change one of those references. So let's change q to point to q.next. Because in our goal, q points to the list node of 4, and that's it. So let's do this. Q is equal to q.next. Great. And let's rearrange these nodes to make it look a little cleaner. Awesome. So we have 3 changes left to make. We need to change p to point to the 3 node. We need to change the 1 node to have a next field of null. And we also need to change the 3 node to point to the 2 node. Are any of these safe? Yeah. So since next, or temp.next and q are both pointing to the 4 node, we're safe to change one of those references. Temp.next, temp.next or q. Well, we don't want to change q, but we really do want to change temp.next to point to the 3 node to get us one step closer to the goal. So let's do that. Temp.next is equal to the 2 node, and we can reach the 2 node by going p.next. Great. We're super close to our goal, and we only have 2 changes left to make. Are any of these safe? Well, both p and the 2 node points to the 1 node. So we're able to change either the P reference or the two nodes next field. The two nodes next field is already in place where we want it to be, but we still need to change P as shown by this green arrow. So let's do that. Let's set P to be whatever temp's pointing to, since we want to set P to the temp node. P is equal to temp. Awesome. There's only a single change left, and that's super easy. We just need to set this one node to have a next field of null instead of pointing to the two node. Great, and this is safe to change because p.next or temp.next are both pointing to the two node. So we can change this third reference of the one node's next field that points to the two node without losing the two node. Let's do this. Yeah, p.next.next.next is equal to null. So I'm just looking over this one more time. The p is pointing to the 3 field. p.next refers to the 2 node. p.next.next refers to the 1 node. And we want to set that next field. So we have to set p.next.next.next to null. Super, yeah, there's so many next, but with some practice, it becomes a little more intuitive, so hang in there. Promise it gets easier. And yeah, now we've reached the desired goal. Isn't that cool? Literally, it's just writing out all possible changes we have to make, and then either choosing one of a single safe change to make along each step, and creating temp variables when necessary and allowed. And yeah, if you want additional practice, definitely check out the Ed slides. Those are great resources. And yeah, have a good one.